So figure 2 shows a sketch of a triangle ABC. And given AB is given by some vector interpretation and AC is another one. Find the size of angle CAB. So CAB is from C to A to B. So I just label that X to make it easy. Now to find this one, it's just a general case of using the general cos formula, which is cos X, cos of the angle, which is equivalent to the two lines in between it, i.e. AB and AC. So we need to use the dot product between these two lines, so AB and AC, and then calculate its magnitude, AB magnitude and AC magnitude. So that's it. To find the dot product, that's easy. It's the second step here, which is AB dot AC. So we literally rewrite these vectors I, J, K into the standard column form, which is 2, 3, negative 2, like this. And the second one as 5, minus 6, and plus 1. The K is just 1, so it'd be 5, minus 6, and 1. Now all you do is just multiply horizontally, as in 2 times 5 is 10, 3 times minus 6 is negative 18, and minus 2 times 1 negative 2. And then you add them up, you collect them, and you get minus 10. That's it. That's your AB dot AC. Very simple. Now for the magnitude, well, just use Pythagoras. So looking at the vectors AB, just square every single term and then square root it. Literally as simple as that. Second one, square every single term, 5 squared, 6 squared, 1 squared, and square root it. So you get root 17 and root 62. Smash it all in, making sure your answer is in degree form, and then cos inverse, and you should get 107.94. Very explanatory, it's just very formula based. Always label what you're doing and it helps. Now let's move on to part B. Okay, so what do we have here? Now find the area of triangle ABC. Oh god, easy. Because now I just updated the diagram from the previous question. Because we obtained all the results, I update X with the correct angle and the correct lengths. Because magnitude is more or less the size of the vector, or in this case, the length. Now using area of a triangle, one way to memorize an area triangle is to always draw a separate triangle and call it the ABC triangle, where the angle C is between A and B. Now looking back at our triangle on the left here, we can see that we got an angle between two lengths. So using the half AB sine C rule, we can say half of A and B, which is root 62 and 17, times sine of the angle C will give us 15.44 units squared. That's it. You don't actually have to write units squared, but I usually do it just something I'm used to doing. You can write units as well to give it some sort of I don't know, some type of unit at least. Now let's look at part C. It's the shortest distance. So here's the values here, and let's have a look. So find the shortest distance from A to BC, giving you answers to 2 decimal places. Now when you have a shortest distance question, the first thing we need to think about is how do you make a short distance? Well, when you think of right angle triangles, the vertical length between them, where the right angle part, is always the shortest length. So we can think of it as the perpendicular length from some line BC to hit A. The perpendicular length is by far the shortest point, because if you did any other line, they would just be like layers of hypotenuses, and they will always be longer than this adjacent line. So always draw a straight perpendicular line from A to B, and let's call it P. Now, what do we have to do? So essentially we need to find the length of AP. Now to do this, there's a cool way to do this actually. I mean, it took me a while to think about this, but the way I presented this is that I'm just using the area of a triangle idea. So since we got a vertical height, we can say that, okay, we have a base here, we have a vertical height. So if we just twist the head a bit, a base here and a vertical height, and we can say that the area of this triangle, as we deduced, was 15.44. So base times height is 15.44, and of course half it obviously. So we can say that our base is BC, we can say our height is AP, and we got area is 15.44. Now we just plug it all in. To find BC, because we probably haven't done that yet, you could use the cosine rule, or you could just be better than I do and just count to find the vector B to C. You just go from B to A and then A to C. We have B to A is just the negative of this, and A to C is the same. So if you're doing the negative of this, it would just be minus 2i plus 5i, which is 3i, minus 3j, minus 6j is minus 9j, and plus 2k plus k is 3k, and then you could find the magnitude of that. That'll give you an answer approximately equal to 9.95. Using the cosine rule is just my favorite. Just treat this the massive length as little a, and the corresponding angle here as 107.94. and call these two lengths root 17, root 62, and just smash away. I'm going to assume that you guys are well versed with the cosine rule, so I'll skip that. Now, yeah, just plug in all your known values, make AP a subject, and you got it. 3.10. Easy. Now, let's go and, let's move on to the next one, number 10. So, almost done, guys, almost done. Now, R cos, R sine, love this one. So, I put a quick recap here. I put the general sine rule for two terms. Should look like this, plus minus, because that's what's required here. Now, A, write 2 sine theta minus cos theta in this form, r sine bracket theta minus alpha, where r and alpha are constants. And this is where alpha is between 0 and 90, and here we need to find the exact value r. And of course, the value of t alpha to one decimal place. Now, this is straightforward. What I do here is I equate these two, because since we're writing this in that form, they're virtually identical. Now, this is cool. Now, for the right hand side, we just need to expand it using the general sine A plus B rule, part of the double angle or the expanded angle formulas. So you should get this in the C3 formula sheet, or I just memorize it because it's easier to memorize and useful. So expanding this one, so we get sine A cos B, so we get sine theta cos alpha, and because it's negative, it'll be a minus sign. And instead of cos A sine B, it'll be cos theta sine alpha. So always invert the letters, invert the trig signs. Now, we look at both sides and we say, okay, to solve this, we need to match coefficients. So I highlighted sine theta and cos theta for a reason, because I want us to match the coefficients on this and this side. We can say that in terms of sine theta, oh man, that was an ugly cough. In terms of sine theta, on the left hand side we have a 2, and for sine theta we have an r times cos alpha. So we say, okay, 2 must be identical to r cos alpha. And now in terms of cos theta, we have a coefficient of 1 here. Because they're both negative, we can ignore negative signs. We have a coefficient of 1 here, and we have sine theta times r. Because remember, r is you're going to multiply r to both. That means the left hand side, the coefficient of 1 is identical to r times sine alpha. And that's it. Now we have two pairs of equation. And yeah, we can now solve for r. So what I did, I just divide these two. Because one thing, the cool trick is that you can make a tan from sine and cos. If you divide sine and cos, you get tan. So dividing the two equations, so this on the top, the first one on the bottom, we should get r sine alpha of r cos alpha equals half. Tan, and then r's cancel out here, and then tan inverse, half, you get 26.6 degrees. And yep, it fits within the desirable range. Now, as for the alpha value, they want the exact value. So unfortunately, you can't just pop this alpha value in and solve for r. No. Actually, you can. If you have the exact answer, if you don't delete the answer in calculator, you could. But anyways, to be safe, I would use the right angle trig triangles. So let's just ignore this root 5 here for a second. Since we got r sine alpha is 1 and this is 2, if we look at tan alpha actually, more particularly, tan alpha is the same as opposite over adjacent. So this is your SOHCAHTOA. This is TOA, so opposite over adjacent. This means opposite that the angle is 1 and adjacent is 2. Now using Pythagoras' theorem, you can deduce and get root 5, because 1 squared plus 2 squared is 5. Square root both of this will give you the length here, root 5. So therefore, using SOHCAHTOA again, to find the sine term is so it's SOH, so it's opposite over hypotenuse. So it's sine alpha equals opposite over hypotenuse. And cos is adjacent over hypotenuse, so we've got 2 over root 5. And that's it. Now plug this into, replace cos and sine or whatever you want, and voila, make r the subject, and you got it, root 5. Yeah, maybe it's a bit long, but this is the form way. I mean, you could also just probably keep the answer here and plug in and see if you get the right answer. I haven't tested that, but I think it should work. Anyway, let's move on, yeah? B. Okay, so I put all the relevant info from the previous question here, just in case we need it. Okay, and of course I put a little cast diagram because it might be relevant for later. So figure 3 shows a sketch of the graph with equation y equals 2 sine theta minus cos theta. Here we go. Ignore the dotted line. Sketch the curve with this equation here. Now looking at it carefully, this is the same equation as the previous question here. Where is it? As 2 sine theta minus cos theta. And because we're writing in this form, we can also say that these two are identical. The only difference is now is that they have an absolute sign. So this means that this curve here has to be always positive for y, because whatever answer you get here, this will force it to give you a positive solution, so y would be positive, meaning you cannot have no negative trace. So that means these should bounce, they should reflect. So it looks a bit like that firstly. Okay, so that's the easy part. Now to find where it actually hits, well, thankfully we could just replace this equation with the arc sine theta minus alpha, or we could just go use the fact that since we're shifting the curve by alpha, because remember sine just is like a regular, it cuts from 0, it's just a regular sine wave. This is shifted by alpha to the right, so it's like it started from this line 0, a bit like this shape, but then the whole curve moved to the right by alpha. So we can see it's moved by alpha, so by 26.6, and originally it's 180, it moves by alpha as well, 206.6. That's it. Now to see where it hits the y-axis, well, that's straightforward. All you do is realize that when something hits the y-axis, the x is usually 0. In our case, the theta is 0. So when theta is 0, plug in theta into any equation that we had. Oh, where did I put my equation? Damn. Oh yeah, put theta in this equation here. You're gonna get sine theta, sine 0, which is 0. Cos 0 is minus 1, so it's gonna be the magnitude of minus 1, which is plus 1, and that's why we get 1 there. Well, how did I forget that? Alright, let's move on to part C. So here we go, guys, almost done. Now the temperature of a warehouse is modeled by this equation. Okay, so once again the absolute value here, and now the only difference here in the previous one is that theta, it has now become 15t. So go ahead and copy the old r sine equation, plug it in, because you can do that, and replace theta at 15t. So that's what we have so thus far. Okay, where and I usually leave it in its original form, not the updated form. Now blah blah blah. So state the maximum value of ft. Now what this means is that we want to get the absolute highest possible of ft, and to do that we need to look at every term. When we look at 5, the maximum value of 5 is 5, because you can't do nothing to it. Now when we look at the bulk of this term, we need to see what we can maximize this to. What I would do is again plug in the r sine equation, which I did over here, and now we ask ourselves, how do we maximize sine? Well, what we could do here is realize that sine takes values between -1 and 1, right? So we can say that the maximum value of sine is going to be 1, because wherever you get the highest possible sine value will be 1, because looking at this curve, well, that's not going to help you. You're going to get a 1. That's it. So that's for sure. So all of this is 1, and because you got r, you can take r outside, so it'll be r times 1, which is just r. So the maximum value of ft is 5 times r, 5 plus r, or 5 plus root 5. Now, next part. State the largest value of t at which this maximum value occurs. And what this means is we have to differentiate now, because when you have a max and minimum problem, they're always talking about the turning point. So it's probably this turning point here or something. We need to find this maximum turning point here. Okay, so just go ahead and differentiate this. So where's the equation gone? So differentiating the equation here, well, 5 becomes nothing. Now don't worry about the absolute sign, it just means that we're going to guarantee a positive solution. So differentiating this, using the usual sign rules, differentiate inside of 15t minus alpha in terms of t, and you should get 15, so that goes outside. You can take r outside as well, because it's always positive. So it'll be 15r times the absolute value of the cos term. Okay, now in this case, and you have to make this equal to 0, because that's the only way to solve for t when you have derivatives and turning points. So make it equal to 0, and then realizing that if you divide 15r, that disappears, and you're left with this term here. Now you just do the easy steps. Now we cos inverse this to get 90 degrees, and realize that to get a maximum value, we can of course see the other values of t. Okay, so what I did, I just highlighted c and a because it's cos, and cos is c and a just means all for positive values. And since we know the angle is 90, we can put 90 there, and I just went around to 270, because 360 minus 90 is 270. And that's it. Since we got that done, this means that 15t minus alpha could be 90, or could also be 270. We want to maximize, so we want to use the 270 value. So we want a heavier upper bound value. That at least the top half needs to be heavier than the bottom half. And then just solve for t. Plus alpha cross, divide by 15, put in a calculator, and voila. 19.8 is our max value. If you chose 90, you would have got a much smaller value, so don't do that. Yeah, anyway, that's it, guys. I mean, I hope that helped, and yeah, let me know what you think. These questions are a bit theoretical, so that's why there's a lot more explanations, and I didn't want to do it as right as I recorded. That would have taken too much time. I like to just quickly break it down and see how it goes. But as usual, if you guys enjoyed it, please give me a like and share with your friends. Otherwise, let's move on to the final parts. Okay. Oh, now this is thick. All right, number 11. So y equals 2x squared minus 3 times tan half x. Okay, oof. I remember doing this. Find the exact value x when y is 0. Now, do what it says, pop in y is 0, so you have an equation like that, equate to 0. And now just make both of these equal to 0, because because the first term times the tan term will be 0. So essentially you have 2x squared minus 3 is 0, tan x over 2 is 0. Now, if you for the first one, just make x subject, so plus 3 divided by 2 square root, you get root 6 over 2. To check if it's between the interval 0 and pi, well, it is, because root 6 over 2 is less than pi and more than 0, so that's fine, that checks out. And that was the only answer because it says exact value, so it's not plural. But to be sure, tan inverse the second equation, tan inverse of 0 is 0, times the 2 across, you still get 0. But unfortunately, 0 is not in the interval, since x is greater than 0, so we cross that out. So our only solution is the first. That's it. You also have a plus minus solution, but again, it's positive, so plus only. Anyway, moving on. Now, given that dy over dx is 0, given that dy dx is 0 when x equals a, show that this equation, the derivative, can be written like that. Okay, all right, let's have a look at this. Now, to do this, if we differentiate this one, we need to use a product rule because you have two different products. So that's why I let u equal the first part and v equal the tan term. Now, differentiating the first one is easy. Drop the power 2 and you get 2 times 2, which is 4x. 3 disappears. Now, for tan, it's a simple case of sec squared. I believe you're given this formula in the mark scheme. I think it's written as tan kx, so differentiate that and k goes outside. Otherwise, if you're not sure how to differentiate this, we need to convert to sine and cos and use the quotient rule to solve it. Anyway, this would give you this result if you did it. And remember, differentiate the inside, so x over 2 becomes half, which goes outside. And again, you rewrite the same term inside as always. Now, let's get back to the main part. So using the product rule, multiply v with u prime to get this term, 4x tan x over 2. Multiply u with v prime, and then tidying up a bit to get something that looks similar to this. So I just put 2x squared minus 3 over 2 and stuck in sec squared after it. Now, here comes the tricky part. So there's various ways to tackle this, but my tip is to always work in sines and cos. So convert tan into sine and cos, and convert sec squared to 1 over cos squared. Now, because it equals 0, fortunately you can just multiply cos squared across, so that cancels out, and this cancels out and you got one more term which goes in the top line, so it looks a bit like that. 4 alpha or 4x sine, it's the sine term and cos term. For the right side, this cancels out, so you're just left with this term here equals 0. Now we have to ask ourselves, how do we get from this to the equation we want? Well, looking at this, the final result has a sine alpha, meaning the alpha 2 was removed. One thing you can also realize that this is actually the perfect expression for, at least most of it, for the double angle sine rule. So remember, if we recall that sine 2 theta is 2 sine theta cos theta, we can look at our equation and realize that the theta here is basically alpha over 2, which is what I did here. That means plugging this in or taking a portion of it. If you just take if you just separate the 4, if you half this value of 4, make 2 there and distribute it, you'll be left with 2 alpha, and this entire term becomes sine 2 times alpha over 2, which is just sine alpha. So all of this part with a 2 in front and isolating it will give us sine alpha. That's it. Yeah, and this is still the same. Now all you do is just simply, now you got this whole equation, just what do we do? Yeah, now you just times it by 2, that cancels out, that becomes a 4, and then rearrange it and it should look a bit like that. Easy. So that was the only tricky part, is to recognize the double angle property here.